Hello, my name's James McNally from Wiresmith Technology, and one of the things we do for our customers is produce custom measurement systems so they can validate their products perform like they think they are, and so we can help provide feedback to the design process. But one of the things that comes up a lot is that data has to be trustworthy, and often, especially when you have test departments and simulation departments and the numbers don't match, you need to know if you can trust the data acquisition system. There's a few things that factor into this that we want to consider, and hopefully we'll do a longer article on that one day. But for today I want to talk about system calibration. The idea behind system calibration is when we have our data acquisition system, there's actually a series of hardware elements involved. There's the sensor, there's some signal conditioning, and there's our data acquisition system, our DAC card. And all of these can introduce their own errors, especially when sensors are more sophisticated, like, say, bridge-based pressure sensors. And so what system calibration does is it says, rather than depending on the individual calibrations of these components, which may be defined by the manufacturer and might be on different calibration schedules, what we're going to do is we're going to take a calibrator, so this is an example of a handheld calibrator from BMX, and we're going to either excite the sensor to the right physical phenomenon, maybe use a temperature chamber or using a pressure pump, or we're going to inject electrical signals and simulate the sensors with the calibrator, and then we're going to measure what the system does, and we're going to produce some calibration curves for the system as a whole, and that way we can see whether these individual components for the errors might add up and become worse, or they might cancel each other out to some element. We get a real calibration for the entire system rather than the individual components. And that has a few advantages, the big one being that now you can do this on your own schedule, you know what the process is that's been gone through, and that can avoid having to send hardware off for recalibration constantly. Now this means that when there's any questions about the results, you can go back and repeat this process as well and go, no, look, we know the sensor's good, we know the data acquisition's good. Obviously this gets simplified as well by National Instruments hardware. One of the reasons that we like working with C-Series and off-the-shelf hardware is that now this signal conditioning and DAC part are one system. So this helps remove the need for this in some cases where the sensors themselves aren't calibratable because the whole unit can be calibrated. So this is a really powerful technique for building trust. There are problems with it and costs associated with it. So obviously you have to have the calibrator hardware. You need something that can generate these signals about 4 to 10 times more accurate than what you're trying to measure. And depending on those signals, that can become very expensive to set up. You need operators that can run the calibration, obviously that's going to take their time as well. And if the individual components drift too far out of calibration, even if you're doing system calibration, what can happen is they can start to introduce some non-linear elements which your calibration won't take account of. So there's still some benefit to having these items individually calibrated periodically as well. But it certainly goes a long way to build trust and give you some control over how you look after your systems. So thank you very much. I hope that's an interesting introduction. Any questions, drop them in the comments, or get in touch with me at www.wiresmithtech.com.